I I love it started like blinking like different colors right as it hit 0.
Yeah.
I wasn't expecting that. I was expecting it just to like cut over to us, but it started going like disco party.
Because it wanted us to be excited, like the
Yeah,
party emoji, like all of the flowing rainbows and whatnot.
exactly. I did enjoy the hydraulic press channel like countdown screen that we had the other day. Um, yeah, that was I don't know. Cindy, good job finding these countdown screens. It's great.
They're very satisfying,
Yeah,
especially, yeah, hydraulic press was probably the most. But the roller coaster was fun too.
yeah.
Like 5 minutes on the ride. Yeah.
I actually never. I didn't see that one. I haven't. I was out for that session and haven't gotten to the live. Well, obviously I wasn't there for the live sync either. Sync watch. I can catch the recording someday, so then I'll know what you all are joking about with the roller coaster. But
Yeah, I think we need one with T-Rexes to follow, one of our talks that had a lot of T-Rexes. I think we need one with like a bunch of T-Rexes just chasing people or something.
Cindy, this is on you. Uh, in other, we're just gonna chat for a moment while people find their way to the live stream. But fun Bang Bang Con fact. We got interviewed today, by a news outlet. I don't know like if there's are you like supposed to like talk about this? I don't know. Is there? I think it's okay.
I think it's perfectly okay. Like they're gonna publish something about Bang Bang Con, so
Yeah, I don't want to like put the pressure on them though and be like, this is gonna be there's this like, you know, I'm sure the article will be amazing, but like I don't want to put pressure on it. Anyway, a couple of us got interviewed today for Business Insider, so specifically about Bang Bang Con and BTS's Bang Bang Con and the overlap and the just the love that we have for BTS fans, and then also just talking about Bang Bang Con and stuff like that. And it was cool. The reporter was super nice, and it was myself and Lindsay and Lindsay Cooper and Julia Evans who did the interview. But the thing that I realized afterward is I was like, wow, this is like the first time that we've had like press about Bang Bang Con. Like all of this, everything that we've built here has been 100% zero marketing spend. That's not true. We spend a little bit, I think, on like MailChimp.
yeah.
Just to maintain our mailing list or whatever. But it's amazing that it has been totally like community driven, totally word of mouth, mostly a lot of Twitter. I know we have some people this year who found us through the BTS mix-up, and are BTS fans, and who found us because of all that. I think I've said it before, but like the most popular thing we've ever done is not be BTS.
Yes. Yeah. So. And the overlap between BTS fans and Bang Bang Con attendees is getting bigger and bigger as we all learn more about BTS every year and watch the concerts. And everyone is excited for Butter, right?
I was just about to say, speaking of tonight, I think it's tonight, right? It says 12 hours left. Let's see. Hold on. It says 12 hours left, and this was posted at noon. So, yeah, in 4 hours, BTS's new single, Butter, is released. Hashtag BTS back with Butter. So,
I think that copyright will not let us put it on stream, but we are hoping that you're gonna check it out when it's out there, and then we can all enjoy it together, but not streaming, just like enjoying it separately on our laptops.
They're apparently going. I heard from an army who said that they were going for like a record of like most consecutive live stream. So I believe they said the record was 3 million, or maybe that's what they're trying to reach tonight. I wasn't entirely sure, but Bang Bang Con, all however many of you are watching, you can pitch in, catch it in 4 hours. BTS's new single drops tonight.
Yeah. Let's help them get the record. So exactly. Next year we'll have a lot of Butter jokes on top of BTS jokes.
All right. We're 5 minutes in. Why don't we go ahead and introduce the talks? Lita, I think you've got the script up.
Yep. Hello, everyone, and welcome to session 7 of BangBangCon 2021. I would like to start with thanking our wonderful sponsors, because thanks to our sponsors, we're able to have such an inclusive and amazing experience. So first, our excellent sponsors this year are Xander and Daily, and our awesome sponsors are Wherewithal, 2 Sigma, Phase Zero, Discourse, Full Story, Accelerated Tech, and Mapbox. And some of our sponsors have been with us for a while, and we're super, super grateful that they keep coming back. And, you know, as we grow, they grow with us. And it's awesome that they allow us to have inclusive ticket prices and to pay our speakers and to pay for amazing AV and stenotaping and everything else that makes BangBangCon. So thank you again for being with us. And as far as marketing goes, maybe it's less marketing and more us just enjoying seeing your tweets and you being happy about the conference. So if you're tweeting about BangBangCon, remember that BTS has taken over our BangBangCon hashtag.
Not that we're upset about it.
We're not upset about it.
No.
We just want to make sure that when you are hashtagging, we are not confusing BTS fans and ARMY with the wrong hashtag. So add virtual to BangBangCon to your hashtag to make sure that we are not colliding anywhere, though it's probably mostly going to be them anyway. And also add BangBangCon is still us, and we still want to make sure all the BTS fans know it's not them, it's just us. So tweet at us, tweet our speakers, especially because, you know, they're sharing their experiences and their fun projects and work and joy of computing. And it would be amazing if you could give them some love on Twitter and share their work as well. It doesn't just have to be us, because this is all about speakers in the community. And, you know, the tiny joy I get from looking at all the Twitter hearts, it's an addition to it. Yeah, so I think everyone is ready. Everyone's watching the stream. And without further ado, we can start with our first talk for today. Do you want to introduce the speaker?
I don't have, I just,
okay.
But I don't actually have the script pulled up. So let me go do that while you introduce the speaker.
Okay, I will introduce our first speaker then. So our first talk title for today is, "Oh no, the lowest level programming language is Unicode aware and I have no excuses." And our speaker is John Heed-Meneed. John Heed, the PhD, is a student. They are the project editor for the C language, and they manage their greatest open source contribution, Sol 2, that is used across many industries and academic disciplines. They are currently working towards earning their own nickname, climbing the academic ladder while spending as much time as possible contributing to C++ standardization and development. Their newest and biggest project is Unicode for C++. Learn more about John Heed's work at their website. They very much love dogs and hope to have their own in a year or so. They also like TWRPS Feels Pretty Good from the album Together Through Time.
Important details.
Good morning, afternoon, evening, everybody. Thank you very much for that wonderful introduction. As I said before, my name is John Heed-Meneed. I run around by the name of the PhD, and this is a talk about Unicode and how I'm sneaking it into the lowest level language possible. Now, when I say lowest level language possible, I don't necessarily mean like assembly, you know, any of that. I'm not writing an assembly library. Oh God, that would be miserable. No, so we're talking about C. We're talking about C. This is the lingua franca that sits beneath almost everything, connects all the languages together. And when you talk to C, you'll be able to talk to everything. And so that's what we're talking about here. That is what we're going for. So, oops. Oh God, that's a perfect error. Sorry about that. I seem to have clicked on the very wrong spot. But anyway, first off, I want to give a big thank you to the people who have kind of contributed to the presentation: Shepherd's Oasis, Arhe, Mohit, and several patrons and sponsors who've kind of been supporting open source work and kind of helped me get here to the get here in the first place. Super glad that all of you contributed. This is some of the sponsors. I didn't quite get all of you, so we have to get a bigger picture at some point. But that's where we're at with that. But thank you very much to all of you. And now, without further ado, let's talk about C. So C is this wonderful language that has a huge reputation for being unsafe and terrible, and not a lot of people like it, or a lot of people like it, depending on who you ask. And whether you like it or you hate it, it sits beneath everything else in your systems, right? It's how operating systems talk to each other. It's how most people talk to their operating systems. It's how most people communicate through one language to another, right? They usually go through a C API or something similar, right? The way you talk to Python and its virtual machine is through C and a bunch of other stuff, right? So this is kind of where we're at right now with C. C has this wonderful thing called locale specific behavior. This is the kind of official definition. It's very, wordy and stuff like that. It talks about nationality and culture and things that come with it. But what you really need to know is that locale specific behavior, and specifically locales, are default configured with the machine. When you get a machine, and whether it's Linux or anything else, if you ever actually paid attention to when you're clicking through the Linux setup screen, it asks you about what's your, where do you live? What's your culture? What time zone do you want to be in, right? All of that stuff goes into locale. And it helps how numbers are formatted, how things like that are work because the way you format a number in Germany and in German culture is very much different from the way you format it in the UK or the United States. And so all of this goes into locale specific behavior. And what this produces very much is kind of a local optimum, right? So if you're in Germany and you're parsing 3D file formats like the OBJ file format, right? And you're parsing a bunch of text floats so that you can display, the bunny or the teacup or the Cornell room or whatever other scene you're working on. That has a very specific form, right? In the way that the numbers are separated and the way that the dots and commas in those floating point numbers are processed, in those decimal numbers are processed. And so if you're on your machine and you never leave your machine, everything kind of works more or less the way you'd expect. One of the fun things about locales that also comes with an encoding, right? So the way you interpret characters as they come through your text files or other streams or whatever else has specific encodings on them, right? And there's a dozen encodings. In the early days, there were over 100. These days, there's so many more. This is just a small sampling from Wikipedia. All the red is the stuff they haven't even managed to document yet. That's how much stuff there is. But basically, this is a situation, right? We have a bunch of text encodings, and they're tied to the locale. And it's like, yeah, I can work finally in my language and what I want to work on. And there are over 200 of them now. Yes, and everyone can speak their own language, and it's great, and it's wonderful. And now we have to share and talk to other people. And now we have to share and talk to other people. So, it's a very interesting situation where we've kind of clowned ourselves. We've made a Tower of Babel situation where we have a bunch of machines. They all output numbers and things like that in different formats. They all have different ways of formatting text, of understanding the bytes in the stream in order to make text, with, a resume with the with the accent mark and everything else. And so that all kind of helps things fall apart a little bit, unfortunately. And so, it's like, well, it can't be that bad, right? How bad is it really? And we have things like UTF-8, this wonderful encoding that encompasses more than just a couple of languages. In fact, this whole point is to encompass all languages. That's what Unicode and UTF-8, which is Unicode Transformation Format 8 for 8 bits. And you can see from this graph, like, we're basically up to about 97% UTF-8 penetration on the web, right? So, like, if we have this UTF-8 thing and it's able to handle all languages, right? And we can handle emojis and we can understand them now. Do we really need to worry about these legacy encodings, these other, all these other things in the list that barely have 2% or even 1% share individually amongst them? And it turns out, people think the problem is solved, right? That if we just use UTF-8 everywhere, we'll get what we need to do, and it's just everything's fine, right? And that you don't need to really worry about it as long as you just use UTF-8, it's great, and whatever else, right? This is a package. This is a package coming from Paris, heading to somewhere in Russia. And as you can see, if you watched Robin Spears' talk earlier this week, you would have seen a thing called Mojibake. And Mojibake is this wonderful thing where text is taken in as one encoding and interpreted as that encoding, but it's the wrong encoding. So everything that comes out on your screen comes out as garbage, right? And so what you have here is that there are people who basically have experienced so much Mojibake in their life. Post office workers, right? People you don't think, when you think about locale and text and the C standard, who have to hand translate the Mojibake that comes on the screen and that comes into their packages because they need to fix the nightmare that's been presented to them that French post office workers don't quite understand as Mojibake, just think that's the way you write Russian, which is not the way you write Russian, but that's how it appears to them, right? So if somebody has to go in with a red pen or whatever else and correct all this garbage, right? it also infects other things, right? You think that the internet would kind of be ready for this, right? I just showed you a slide where like 97.6% by April 2021 is where all the number of websites that had UTF-8 support, right? Unicode support, right? For emojis and whatever else. And yet we have the internet, an international standards organization that can't handle names with accents in them, right? So did we really solve the problem? Are we really there yet? Have we actually conquered the beast here? And of course, we have even more hilarious stories, right? The fact that the German government, who's it's their language, right? That has umlauts, right? It's their language. It's native to them. That's the way. That's one of the primary reasons why we have it in Unicode. Why we are able to have umlauts, why we speak it. And the German government can't even handle the names of their own native people, right? Like, so have we actually successfully conquered? Have we gotten over locales? Have we managed to fix this problem of all the different machines being able to talk to each other and handle different kinds of data? Okay, so it's bad, right? It's kind of bad. So how do we fix this mess? How do we make it so that these things work out for us, right? To the point where we can actually do work on them? Well, it turns out that there aren't a lot of utilities in the C and C++ standards. C includes C by, the C library by reference. There's not a lot in C that actually is there to fix this, right? They have a bunch of functions and stuff to handle specific things, but they don't really go any further than that. So what I did is that about 3 years ago, or 2 years ago at this point, I've been working on it for 3 years, but about 2 years ago at this point, 2 years and some change, I sent an email basically to a man named Rajan Bhakta, and he sits on the PL22.16. He's one of the PL22.16 chairs, and he's basically sits on the C committee. And so I bombard him with emails like, listen, I need to fix this, right? Like, I can't deal with the default locale on some of these machines and everything else not being UTF-8, not being able to handle the majority of text in the world, right? So that's how I started. Right? I just sent him an email, cold turkey. I wasn't the project editor at this time. I had no idea what I was doing. I just had to fix it, right? I couldn't wait any longer. So I sent him a cold email. And from there, it began to snowball, right? So I hit the ground running, and I gave a talk at CPPCon about the way we're going to add Unicode to C++ and inevitably to C in order to make this stuff work, right? So the idea is that, if I can fix these low-level languages, if I can get Unicode into these low-level languages, then I can start fixing things myself, right? Then we can enable these governments, these people, these post office workers to have an experience that isn't burdened down in legacy for a million years because somebody says, oh, well, we can't really deal with anything outside of ASCII or Latin 1, or we can't handle Hebrew or anything else like that, right? And so I just kept running. And so I finally built a library that was proving out some of the standards work that I was doing to show that it was possible. And I kept going and kept going and kept going. And I have to keep fighting, right? So this is a kind of a diagram of some of the functions you get for converting between one kind of character set to another. You can see there's a lot of red here and a lot of empty space here, showing that it's not implemented. And I finally, after a lot of struggling, started proposing and fixing some of this and stuff. Some of this stuff actually might make it into the C standard at some point. And so you're struggling and you're fighting and you're doing all this work and succeeding. Well, the thing is, it's still kind of a work in progress. And while my goal is to make it so there's still technical excuses, there can still be other excuses. And so what I want to really emphasize is that while I'm working on getting Unicode into low-level languages and make sure there's no more technical excuses, there's still people who think that, oh, we can support Latin but not Hebrew, or we can support this language but not maybe Chinese or Japanese. And so there's a lot more work that needs to be done, even on the global level, right, where you have much more larger nations and nation states that refuse to allow things like accent marks and names and everything else. And so there's a lot more to be done. And will I succeed? Will we make it? I mean, a little bit open-ended, but hopefully by the time this is all done, we'll get to a place where everybody's names can be spelled correctly, everybody's passwords can be handled, nobody gets stopped for random inspection by the TSA because what's printed on their pass, because the computer couldn't handle it, doesn't match their actual ID from their country and stuff like that. And, well, that's hopefully what we're going to be going for here. And hopefully the next time I give a talk like this at Bang Bang Con or somewhere else, it'll be talking about the success and the way that we finally managed to fix this problem and stop mangling and ruining people's names and lives and dates. Thanks.
Thank you, John Heed, for your work on all of this.
Yeah, as a non-native English speaker, I really appreciate it. I mean, I blacked out that my name only has ASCII letters in it, and the same for my partner. But for most Polish people, it's not easy being an immigrant. Just filling out the forms is a whole journey for a lot of us. So, if I hope that you hear a lot from people how they appreciate your work on trying to get this up to speed and making sure that everyone is included in conversations, no matter how you spell their name.
I was just saying in chat. There's the common term like rage quit. You know, like when you get so angry that you just like quit. But I want to see more rage join. Like you're like, this is wrong, so I'm gonna join the committee and fix it. submit proposals to make this happen. That's great. We need more of that in the world.
Yeah.
So. Okay. I have the script up, so I can introduce our next talk.
Perfect.
All right. Our next talk is Enter the Minus World. Nintendo Cartridges Share Secrets by Paul Pollock. Paul has a lot of hobbies and interests that move in and out of rotation over time. Sometimes he forgets one for years and then suddenly remembers he liked doing the thing. Among these are electronics, music, mushroom hunting, and watching the Evil Dead trilogy. Paul writes software to make it easier for people to spend time outdoors for the Wanderlust group.
Welcome to my talk, Enter the Minus World. Nintendo Cartridges Share Secrets. I want to talk to you about a console I love, the Nintendo Entertainment System. I also want to talk to you about a game I love, the Super Mario Brothers game. I also want to talk to you about a game I am ambivalent about, tennis. But I'm only going to talk about it because it's involved in a cool and weird thing we can do in Super Mario Brothers. So one of the reasons why I like this game so much, and this is definitely not unique about me, is that there are all these cool secrets. The warp zone is one of my favorite examples. It was really cool as a kid to be able to find a secret room in the back of a level and go somewhere far into the future in the game without being actually good enough to play the game and get there. I think things like this definitely encouraged gamers who are maybe kind of tenacious to find all the secrets they could, eventually finding out how to break the game in very interesting ways. The minus world glitch here is a very famous example. We can evade the collision detection logic in the game and jump in a very specific way. We slide through a wall, we go down a warp pipe before the proper data is loaded into RAM, and we go to this underwater level called simply -1. It's missing the world. When we finish the level, we just kind of wrap around and start over again. And we do that over and over and over again until we get bored and turn off the game or get a game over. This was really cool, and people were really excited about it when it was discovered. Nintendo Power wrote it up in their 3rd issue, but it's a little limited, right? I want to show you something that I think is cool and not quite so limited. Japanese gamers had figured out a technique to get to 256 bizarre worlds. Shigeru Miyamoto, the creator of the series, was so inspired by this that when they made the sequel, they actually added an extra 9th world that was very reminiscent aesthetically of the types of things people were finding. So it's called the undercover trick. And the reason why it was getting a lot of heat in Japan was because you could do it on this, the Famicom, the original Japanese console. You can also do it on this. This is the NES 101 top loader, is what I do it on. But that didn't come out until very late in the life cycle of this console. At the time, US gamers were stuck with the NES. And the reason why they couldn't do this trick is because of this horrible beast. This is the 10 NES lockout chip. It was basically a mechanism that Nintendo introduced to enforce aggressive licensing decisions they made when they came to the US console market. Unless you had their seal of approval, they didn't want your game running on the console. So if you didn't have it, it would go into an infinite reset loop. The bad news is that the chip was bad, and so were some of the mechanical elements of the console. So a lot of consoles went into that infinite reset loop for perfectly approved games anyway. That happened to my childhood NES, and it was really sad. So that aside, how do we do the undercover trick? We start by playing some Super Mario Brothers. Makes sense. We want to get some of the data in working RAM, and we're just going to hang out on a pipe where it's safe. Don't turn off the console because we just did a lot of hard work and we don't want to erase it. Take the cartridge out, just like they tell you not to. Put tennis in. Something very interesting happens there visually when the cartridge makes contact. We'll talk about that in detail. We reset the console. We play a little tennis. I don't play much tennis because it doesn't go very well for me. Same thing. Keep the console on, remove it. Super Mario Brothers goes back in, reset. So this is important. Don't just press start because we'll just start from the beginning of the game again, and nothing we just did will matter. A+ start is a special input that allowed you to continue from the last world you were on after you got a game over. We weren't playing Super Mario Brothers, though. We were playing tennis. So instead, we start somewhere very weird. So weird enemy spawns, empty item blocks hidden underground. This was clearly not designed, right? Let's look at one more example. This one's a little less exciting. What can you do about that? So we're going to look at another example a little later, but first I want to show you some hardware. This is the motherboard of the NES. On the left here, we have the CPU. It's based on the 6502, which was a really important microprocessor of this era. It was in the Apple II, the Commodore 64. There was a variant in the Atari 2600. There's a really fascinating history around things Nintendo and Ricoh, a Japanese manufacturer they worked with, did to evade patent law, pretty much, because they felt like they had to enter the US console market to produce their variant. I have a book cited at the end of my slides that goes into that in detail, and I highly recommend it if you're interested in learning more. The other chip we're interested in here is the PPU, the picture processing unit, also made by Ricoh. This was basically like a graphics card. As opposed to the 6502, which was ubiquitous in computers, this was very unique to the NES. It made developing very, very easy compared to the Atari 2600, where programmers had to render scan line by scan line. This abstracted a lot of those complexities away. We're interested in some stuff on the cartridge too. I opened up a Super Mario Bros. Duck Hunt combo cartridge here to show you some read-only memory. We have character ROM here on the left, and that is basically graphical information. It connects right to the PPU. And on the right, we have program ROM. This is source code. It's the game logic that goes right to the CPU. Take note of the very distinct physical split in the pins coming from these chips. I think it's very illustrative, and I hope this simplistic diagram is too, of how these components work, which is very independently of each other. The CPU and PPU each maintain their own independent address spaces. The CPU has 2 kilobytes of working RAM. The program ROM takes up a lot of space there. The PPU is doing a lot of stuff with character ROM, like background and foreground imagery. The way they communicate predominantly is through these 8 bits on the CPU address bus that are PPU registers that PPU makes it accessible to the CPU. They do very specific operations. One important way that this happens is it allows the CPU to manipulate object attribute memory. Every frame, the CPU can tell the PPU where up to 64 sprites can be on screen at any given time. So this is responding to input and gameplay. So we're playing Super Mario Brothers and everything's going well. And then we do something very rude and we unceremoniously remove Super Mario Brothers cartridge. The CPU is mad at us and doesn't want to do anything for us anymore. But the PPU tries to be pretty helpful, and it still tries to render the last data that it had. There's no character ROM though, so there's decay. When we put tennis in, the CPU is still down for the count, but the PPU says, oh, cool, character ROM's back. I know where tiles are supposed to be, and I know which ones I'm supposed to use. So we have a pipe made out of tennis nets. We have a Mario made out of a bizarre assortment of tennis player parts, and we have a status bar that is quite readable. If we look at the way that the character ROM is laid out in sequence on these cartridges side by side, it all makes sense. And specifically, if you look in the middle, those alphanumeric characters are very, very similar with very few differences. This makes sense from a practical standpoint, too. These games were both developed in-house by Nintendo, so developers were likely sharing resources, making their lives easier. So that kind of explains what happens visually when we swap out those cartridges. So what's up with these worlds? How come Copyright World and Mushroom World exist, and how come levels actually have layouts for them? The answer lies in an address in RAM, and it is hexadecimal 7FD. In this address is stored a byte that is the number of steps that we take in tennis. It is also the continue world in Super Mario Brothers. So when we play tennis, it changes that value to the number of steps we take. We have some pretty good control over that. When we play Super Mario Brothers, we press A+ start, and it fetches that byte. Typically, it expects to go to worlds 1 through 8, but this can be 256 things. So it kicks off a subroutine that uses an offset to go to what should be a meticulously laid out sequence of bytes, but it's just kind of an arbitrary place in program ROM because we started at an arbitrary place. So knowing all this, let's take one last look at the minus world. Sometimes these are really exciting, sometimes they're not. This is, I hope, the best one I was able to find that you all enjoy. Yeah, the Koopas have very uncharitable spawns here. It's always a treat to get an underwater level above ground. The thing that I really love most about all of this is that I think it illustrates how flexible the design of this game is. And it's just kind of strangely beautiful what can happen if you put the wrong number in the right location. So I have one more quick clip that I can share with you guys. Most worlds have 4 levels. This one has 6, which is really weird, but maybe I don't have too much time to get into that after all. So here are some sources that I put together. They were super helpful when I was doing all this. I Am Error is a fantastic book, very comprehensive look at the NES and Famicom. It kind of got me really interested in doing more stuff with the NES than just playing games on it. Legends of Localization is a fantastic website, typically focused on translation of classic games. The NES dev community is just the best place for all kinds of technical knowledge on the NES. I use some tools made by their community members. Nesplorer is where I was able to load ROM files and get those character ROM images. And the disassembly of Super Mario Brothers. It's incredible. It saved me probably hours of finding what the continue world value is in Mario. I just had to confirm that and then find out what it did in tennis. I'm planning to stream some Minus World stuff at some point. I'm not a Twitch streamer. This could be a huge tire fire. I've confirmed that technically my setup works, but I don't know. If you want to see Minus World stuff or something go really bad in real time, check it out. Thanks again, and I hope you all enjoy the rest of Bang Bang Con.
Thank you. That was super cool. Oh my gosh, Minus World. I'm gonna have to read that book. I Am Error.
Yeah, as someone who, as I must admit, I'm not a fan of Mario. I did not grow up with this, so to me it was always kind of interesting that people were into it. But it was pretty cool. Yeah, discovering secret parts of your favorite games and how things actually work and reverse engineering them through trying different cartridges. Like, this is awesome.
I love the idea that it just like tries to be helpful, and so you put another game in, and it's like, okay, that's fine. I can keep rendering this.
Let's figure it out. Let's put some Mario together with tennis boards.
Yeah, I feel like that doesn't work anymore. You know, this is a true, like, they don't make them like they used to kind of a thing.
Imagine what kind of games you could like take, I don't know, The Witcher and then Animal Crossing, and you can mash them together.
You just need the RAM layout to be exactly the same. You know, no big deal. All right, let's roll right into our next talk. All right, our next talk is Option Hack That 30-Year-Old Oscilloscope by Tom Verbura. Tom spends most of his time in his garage during the day to help create awesome gaming monitors, in the evening to work on one of his 20-plus parallel hobby electronics projects. By writing about them on his blog, he forces himself to finish a project every once in a while.
For Tektronix oscilloscope to a tool called GL Scope Client. It's a tool that allows you to post-process data acquired by oscilloscopes on your PC. Now, I didn't have a Tektronix oscilloscope, but I was able to find one on eBay for $160. So I bought that one, and when it arrived home, it worked. Now, one of the things I had to check first was whether it or not had issues with leaky capacitors. An interesting thing is that in the early 90s, there was a lot of capacitors produced that were actually broken. And after a couple of years, like 5-10 years, the electrolytics would start leaking out of it and corrode the board. And this is still an issue when you buy electronics from that era. For example, all the Macintoshes and stuff, very often you will have to replace these capacitors, otherwise they don't work. But mine was okay. It was produced in 1996, so there was no issue anymore. Now, oscilloscopes these days, and back then already too, they come typically with a bare bones functionality, and then you pay extra money for additional options. In my case, the basic options were a port to control printers of that day, and a floppy drive, not very interesting. There were three other options that the scope supports. One is the video trigger interface for PAL and NTSC, which is now obsolete as well. There is the advanced DSP option, which allows you to do stuff like FFTs on the incoming signals. But most important, there is the option to have a sample buffer of 120,000 samples instead of the standard of 30,000 samples. So here you can see what those two first options can do, the video and the DSP. It's basically a software option, so I didn't expect there to be major issues with that. But for the 120,000 options, you need enough RAM. So the first thing I did was count, is there enough RAM on the board? And it turns out, yes, there are basically 16 32 kilobyte RAMs. That's basically 128 kilobytes per channel. And so I thought, okay, well, this looks good. All I need to find now is how to enable that function. Well, the first step to get there is you need to extract the firmware. And this is a process that's relatively well documented on the web. It requires switching some toggle inside the oscilloscope with a little screwdriver. And then with a GPIB interface, it's an interface that's used in the 90s and earlier for almost all test and measurement equipment. You can basically read out the firmware. And so once you have that, you can use the strings command in Unix to check, well, is there anything interesting in there? And one of those things is, you know, the VxWorks logo. VxWorks is the operating system. It's currently still used for automotive, medical equipment, robotics. It's even on the Mars 2020 lander. It's very good for embedded systems, has lots of real-time features. Another thing that I found is a whole menu for commands, and that's a good thing because it means there is a console in there somewhere, a debug console, that will probably help me executing commands and figuring how things work. And then most important, there is a functions symbol table. And that's really the holy grail of reverse engineering because it allows you to annotate binary code and figure out what the code is doing without having to guess. So the next step is getting a serial debug console up and running. So you basically have to remove the casing of the oscilloscope, and then there is another RS-232 interface. And I was hoping that I could use the same internal cable that was also used for the printer. Well, it turns out that in all their wisdom, Tektronix used a different pin assignment. In fact, the pin assignment was 180 degrees different than what I need. So I had to rig up something myself, but eventually I was able to get that to work as well. And so then when you boot up the scope, you see all the boot up messages and everything was looking fine. And finally, you get a command line. And what I figured out is that the symbol table is included because all the symbols that are in there can not only be called by regular C functions, but you can also type them on the command line. VxWorks supports that. And so there is a separate process running in the operating system, and it takes in these commands and just executes them. For example, you have the ring bell function. And if you type ring bell on the command line, you have a bell going on. So the next step then was to look at what the code was actually really doing. And for that, I used a tool called Ghidra. It's an open source tool created by the National Security Administration of all people. And it allows you to read in a binary image and a symbol table, and it will then reverse engineer the assembler code back into C code. It supports all the popular CPUs from today and also from the past, including the Motorola 6802 that is used in this oscilloscope. So for example, here you see the ring bell function. It's obviously very simple. It checks, first of all, is the bell enabled in software? And if so, then when you want to ring the bell, you need to write a value of 10 hex to the register port A, and the bell will ring. And this is really very useful to quickly determine how hardware is working. Now, you don't really always need a symbol table. For example, the boot ROM does not have a symbol table, yet it prints out a lot of diagnostic messages, and those are fantastic pointers to figure out what certain code is doing. For example, in the code here below, you can see that it's printing out GPIB test passed. Well, from that you can figure out that the code before that must be testing the GPIB. And so then you can, in Ghidra, annotate these functions with a nondescript name, with a descript name. And as you do that, eventually you can figure out what the whole code is doing if you just spend enough time on it. It's like a game of following breadcrumbs in the forest. Now, so it turned out that one of the most important features or functions is the hardware accountant query function. In a Tektronix oscilloscope, there are 16-bit feature numbers, and so every hardware feature has this unique number. And I could figure out that there's a whole bunch of them, including the 3 that I was looking for. You have one function, the 2B8, and that returns 30,000. That's basically the 30,000 points that is currently supported in the oscilloscope. Then 317 is the math pack, that's the DSP function that I'm looking for. And 700 hex is hardware probe TV trig present. So let's look into one of those. Hardware TV trig present turns out to be very simple. All it does, it reads from a fixed location in non-volatile flash memory. And when that location is 1, then it says, okay, now that feature is enabled. And the same thing was true for the math function. So one of the other functions is libmanager word at put, which writes into the non-volatile flash. And so on the console, I could simply give the 2 commands to set these values to 1, and you reboot the scope. And wouldn't you know it, suddenly those 2 features are enabled. It was really that simple. And so you can see on the left, indeed, there is now the video trigger menu enabled. And on the right, you can see the FFT of a square waveform. Now, for the 120,000 samples options, things were not that easy, because there the feature check not only checked whether that particular non-volatile memory location was set to 1, but it also had a function that actually checked if a certain memory was big enough. And that function failed, which is weird because I thought there were enough RAMs, but it gave me a clue that maybe I was looking in the wrong place. And indeed, there it turns out to be another plugin board in that oscilloscope on which there were 6 RAMs missing. And so that's the reason why the function didn't work. Now, these RAMs are very old, of course. They're not in production anymore. But there are these second-hand brokers in China that will basically sell refurbished RAMs. And so I ordered 6 of these RAMs, soldered them on the board, set the non-volatile function to 1, and upon the next boot, the 1M function, which is the 120K option, it worked. So basically I had a total success. All the options that were disabled were now working. Now I want to spend one final minute on Smalltalk. Smalltalk is one of the first object-oriented languages. And it was really quite, people were hoping it would become possible somewhere in the 80s, and Tektronix was really betting on that. In fact, they had quite an extensive line of AI workstations that were running on Smalltalk. Now, this thing clearly didn't really go anywhere, and eventually the Smalltalk infrastructure moved to their oscilloscopes and other test and measurement equipment, including this particular scope. Now, unfortunately, there's almost no information to be found. I mean, there are some hints that the floppy disk could be used to install extensions to the scope that might be Smalltalk based, but I really can't find anything about it, and that's really a pity. Tektronix basically eventually started to phase out Smalltalk, and by the end of the 90s, all their new equipment was using Windows, and that was the end of the Smalltalk story. You can find much more information about all of this on my blog. I have an extensive 5 blog post series about this whole reverse engineering effort. There's also some info on GL Scope Client, and you can follow me on Twitter. And thank you very much.
Thank you. What a fun hack.
I would be terrified of doing that, especially seeing some comments on Discord like, oh, like the smell of this thing blowing up. I'm like, oh, okay. I haven't done enough hardware hacking in my life to
Yeah,
know
I'm
that there
definitely
is a smell.
not on that level. All I know is you just have to not let the magic smoke out. Like that's yeah, exactly. Okay. Yeah, we're clearly out of our depth here. A hardware talk given to two software engineers. So make fun of us on Discord or something. Oh my gosh. But I was actually he mentioned Apple II, and I have an old Apple II that a family friend had in their attic for like I don't know 20 years. And they were going to throw it out. And so I was like, no, like, that's okay. Like, I'll take it home. And I'm dreading opening it up and just having it be like all capacitors, like needing to replace every capacitor. I haven't actually opened it up yet. I managed to get it to turn on, but half the keys on the keyboard don't work. So it's going to be an adventure in the future, maybe. When my kid gets older, we'll do it as a father-daughter bonding exercise.
Yeah, just some exploration and Zen connecting over fixing something. Yeah,
Exactly.
hopefully.
Exactly. All right. Do you want to introduce this? Last talk?
Yes. So our last talk for the day is compilers hate him. Use this one weird trick to hide a message in your x86 program. Our speaker is William Woodruff. William Woodruff is a security researcher at Trail of Bits, primarily doing DARPA-funded research into program, LLVM, and binary x86 analysis. During his free time, he likes to blog, ride bicycles, and do a bit of open source work, most recently in Rust. He's slowly working on completing the system of German transcendental idealism.
Hello. Unfortunately, you are muted, and I am here to tell you that. Let's take that from the top. Oh,
can you hear me now?
Yes.
Very sorry about that. Okay, sorry about that. Like I was saying, my name is William, and this is one weird trick you can use to hide a message in your x86 program. So first, let's talk briefly about steganography. Steganography is the art of hiding data within data. It comes from these two Greek words, and I like to think of it personally as cryptography's less formal and less useful sibling in most cases. It does have a few limited uses in the form of covert channels and secret metadata. You often one famous use of it was actually in an MMORPG to hide secret messages to find secret servers being run by unauthorized users, and also you see it being used for fun by CDF players. But in general, it's sort of less useful than the more formal domain of cryptography. However, to get briefly into it, the theory of operation behind almost all steganographic techniques is you take some input format whose contents can plausibly vary very slightly and encode secret messages within those variations. A good example of this is the RGB 24-bit color space. These two colors below are nearly identical. They're 1 bit off, and human beings can't tell the difference, but a computer certainly can. So if we take an input file that's encoded using the 24-bit RGB color space, and we tweak these values very slightly, we can use those tweaked bits to hide a message that only other people in the know can decode. This talk isn't going to be about steg using run-of-the-mill formats like images, video, audio, or text files, but just for motivation, in this case, these two commands below hide and extract a picture of DB Cooper from this picture of Bigfoot. And here's that file. I'll upload the slides later, and you can actually try this for yourself. But this file actually has another image hidden within it, and obviously you wouldn't be able to know this unless you wouldn't be able to extract unless you knew ahead of time that it was encoded using steghide, which is a publicly available tool. You can install it from Ubuntu or any other Linux distro. So let's talk about steg on computer programs. So first we have to ask, what would it look like to actually steg a compiled binary? Unlike the formats that I talked about before, image formats, video formats, audio formats, you can't do small changes, small perturbations to computer programs. Small changes to computer programs produce significant behavioral changes. Flipping a single bit willy-nilly means changing an add into a sub, or changing your operands drastically in ways that fundamentally break the correctness of the program. Transformations also have to preserve environmental assumptions like binary relocations, relative addressing, and offsets within the compiled binary, because these environmental assumptions are made when loading the binary, when executing it, or when loading it into another binary, or anything else of that sort. So we can't just go around changing things willy-nilly the way we can for an image file. So to understand how we're going to do this, we have to talk a little bit about x86-64. A key thing to understand about x86-64 is that it's a massive and ancient ISA. You can trace its lineage all the way back to 1972 with the 8008. And it's basically been stable with the exception of a bunch of extensions since 2003 with the AMD 64-bit extension to the original architecture. It's known as a CISC architecture, which means it's complex instead of RISC, which is reduced. And one of its relatively unique features is that it has a variable length encoding up to 15 bytes. It's also a register memory architecture, which means that its operations can actually take either register or memory operands, in contrast to a load store architecture, which can only take register operands for most operations, and they're separate operations that load values into registers. And these last 2 points make x86 a very, very different ISA, conceptually and in terms of encoding, from RISC or even just relatively simple architectures like ARM, MIPS, RISC-V. Even other CISC architectures are not nearly as complicated as x86 is. So to get into things, here's a visualization of x86's instruction format. This is an over approximation of x86's format, but it gives you an idea of sort of the complexity we're dealing with. And for the purposes of this technique, we're only going to look at exactly 2 of these bytes. We're going to look at the opcode byte and the mod-rm byte. I'll talk a little bit about those in a moment. So to understand what these bytes do, you have to understand that x86 has a whole lot of different ways to encode operands, and one of the ways it does that is the mod-rm byte. The mod-rm byte encodes 2 different kinds of operand, or rather 3 different kinds of operand techniques. It encodes register-to-register operations, register-to-memory operations, and memory-to-register operations. So you see those 3 above. You can do, add 2 registers together, add a register and a memory location into a register, or add a register and a memory location into the memory location. The way that the mod-rm byte encodes those is with this mode selector, followed by a register selector, followed by a register or memory selector, depending on the value of mode. 64-bit x86 complicates this a little bit by adding the rex-r and rex-b bits, but the essential mode of operation is the same. So a key thing that I kind of glazed over there intentionally is that mod-rm reg and mod-rm rm encode 4 possible states, and yet there are only 3 encoding forms. And so what's going on here? And the answer is, if we go back one, the operand order that you see here of EAX, EBX, or EAX, EBX, with EBX being a register operand, rather a memory operand, that order is controlled by the operand opcode direction bit. So there's another bit inside of that, opcode byte that I mentioned earlier that controls the direction of these operands. So there's actually 4 possible states, but only 3 encoding forms. And what that means is there's actually 2 different ways to encode register operands using the mod-rm byte in x86. This isn't really documented anywhere, but it's sort of it's a logical consequence of how the mod-rm byte works with the direction bit inside of the opcode. This is exactly that. If you actually look at x86's opcode tables, these ones are from the Intel Software Development Manual, you'll see that there are 2 different, or at least 2 different variants for many opcodes that have a mod-rmr variant and an add-rmr or an add-rrm variant. These 2 have identical semantics when they're used in register mode, but they have different semantics based on the direction bit when they're used in register memory or memory register mode. So what you'll see here is you have 2 encodings that have the same length, right? They have they're both 0103 followed by the mod-rm byte for the actual operand encoding. So they're both 2 bytes long. They have identical semantics, so they both add. They both have the same flags operations. They have the same timing behavior, etc. But we can select between them for 1 bit of steganographic information. So every time we see an instruction that looks like this in a program, we can encode 1 bit of information by twiddling that encoding. So the cool thing about this is this actually works for more than just add. It works for a key subset of x86 instructions. It works for add carry, sub borrow, and XOR, or XOR mov and comp. All of which, fortunately for us, except for add carry and sub borrow, are extremely common in x86 binaries. And even though I mentioned that it's a little bit different in x86 64, this all still works in 64-bit code because the basic operation of the mod-rm byte is still preserved, even with the rex prefix. So we can actually use this on like a massive swath of x86's encoded operand space, at least for common binaries. So to put this all together, we're going to take our secret message and we're going to code into a secret bit string. We're then going to take our target program and pass it through an x86 instruction decoder to get our decoded semantics. We're going to iterate through each of those, and then we're going to rewrite them to match the secret bit string. So we'll select one or the other based on which bit in the bit string we want to encode. Finally, we'll write that out as our new fully functional executable that contains our secret message. I'll quickly walk through the code for this. Like I said, there's a whole bunch of operations we can use. Add is shown below. There's 4 possible variants. This isn't exactly how it works at the disassembler at the binary level, but this is how the disassembler sees things. In order to understand how much information we can actually pack in, we have to profile the binary. So that's what we're doing here. We're basically just moving through every instruction in the program and checking whether it's in our supported opcodes, whether it's a register operation, since that's the only kind we can flip, and then we save it if it is. And then finally, to actually do our rewrite, we're going to select the new code, which is either that add 01 or add 03 variant, based on whether or not we need to encode a particular bit of information. So in one case, we're already correctly encoded. In the other 2 cases, we just have to swap based on the pairs we had earlier. And then we just take that new code. We take our operand registers as before, or rather our register operands as before, and we use our encoder to produce a brand new instruction that we splice directly into our copy of the program's instruction text. And that's that. So I'm going to drop this slide really quickly because I'm going to do a live demo of this. And if everything goes right, hopefully this screen is shared and everybody can see this. So what I have here on the right-hand side is a picture of Bugs Bunny and Stalin. I've already loaded these commands here. You can see that I have a copy of Wireshark installed at user bin, has this checksum. Bugs has this checksum. And you can see that I've profiled this binary already, and it has about 23 kilobytes of space available. So if everything goes right, what I'll be able to do is this. I'll be able to do, and I'm going to save it into my own copy of Wireshark, and I'm going to load Bugs into it. Now, I have a copy of Wireshark here that is, you'll notice, different in terms of its checksum from the initial one. These two, differ. But if I run it, I have to. I apologize for the loud keyboard. You'll notice it is a perfectly functional version of Wireshark. I can move around a little bit, but I want to be fast. Anyways, if I do stack86 extract Wireshark and I pump this into FEP, you will see that I in fact have a hidden copy of Bugs inside of this binary. And if I do into SHA-SUM, you will see. I don't have history. That this checksum matches our initial input. So there you have it. That is a way to hide a message inside of an arbitrary binary without breaking it, using this one weird trick inside of x86's operand encoding. I hope you enjoyed my talk. If you did, I'm going to put the slides for it up in a moment, and the source is available on GitHub under Woodruff W stack86. And of course, you can follow me and talk to me on the Bluebird site at 8x5CLPW2. Thank you.
This was awesome. Now I wonder
Wow.
what's hidden in my program. So I'm like, do I have any versions of like some hidden Easter eggs or something, and I just don't know about it because I don't know how to run them?
People were pointing out that Bugs Bunny was a bold choice for a live demo because you don't want any bugs in your live demo. Hey.
Bang, bang, bang.
Oh my gosh. Well, all right. Speaking of Bang Bang Con. Sorry, I didn't have a good segue there.
Yes, speaking of Bang Bang Con.
Speaking of Bang Bang Con, which we are at right now. Oh, geez, gonna knock my background over. Tonight is our session of unconferencing. And unconferencing is where you, our participants who bought tickets, get to hang out with other participants who bought tickets and basically propose your own sessions and then hang out together and talk about those things. And we have put a link to a spreadsheet on our Discord that has sessions and sign-up slots. Feel free to propose a new session right now, feel free to sign up for something. And then in Discord, we have some voice channels. I'm sorry, wait, are we doing it in Skittish or Discord?
So we're doing some of them in Discord because you can't screen share in Skittish yet. So I know
okay.
some folks ask us for Discord ones because you can screen share things.
We should like put that in the. I'm going to insert one left, and we're going to say where is it? Because it looks like the playing with debuggers is in Discord, and live coding on Twitch is in Skittish.
Yes.
Cool. We've had talks. Please feel free to propose anything that is Bang Bang Con technology fun related. We have had, well, even just this year, we have talks about playing around with debuggers or live coding on Twitch. I remember in 2018, I think we had a talk about union organizing. Whatever, whatever is interesting to you, please go ahead and throw something into that unconferencing sign-up sheet. Sign up, and then it is going to start basically whenever people show up to it, because it is already at the hour. Am I missing anything?
For a conference? No. We don't have. Also, we scheduled an hour for it, but if you feel like talking for longer than an hour, feel free to do so. There's no limit. We just
it's not like
get started after the talks.
Yeah, exactly. It's not like the custodians come through and kick us out at some hour or something. This is the benefits to the virtual conference format.
So,
yes, and also speaking of globally accessible spreadsheets, make sure to check out the Bang Bang Con spreadsheet party. It's happening again this year. It's a globally editable Google Sheets spreadsheet. I almost said Google Slides, which was wrong. Google Sheets sheet, and we're all just having fun in there, making numbers and charts and colors and things like that. Oh, that's what I was going to do. I was going to pull up. I was like switching through my tabs, trying to figure out what I was going to do. But I wanted to say we also have a second hour of unconferencing this Saturday at, and I'm not going to get all the time zones here. Actually, I'll just say right after our keynote. So we'll announce it then again. But if you come up with something between now and then that would be a good topic, please feel free to add it to that spreadsheet so that people can sign up for it in advance and so that people can get excited about your unconferencing session. Yes, and then the only last bit of business is just our live stream. Do you want to announce the live stream?
Sure. I have all the hours written out, so I can actually say all the time zones. So
in the script, look at that! Wow.
Yeah, the script is so helpful. It's useful to have it on hand. So the live stream happens for this talk tomorrow, and that's at 11:30 p.m. IST, 8 p.m. CST, 7 p.m. BST, 2 p.m. Eastern, and 11 a.m. Pacific. So if you hadn't had a chance to maybe see all the talks, or you want to go through some of them in more detail, I know I need to go through some of them in more detail, join us tomorrow. And then the next session happens tomorrow as well, in the evening North American time. So that's 5:30 a.m. IST, 2 a.m. CST, 1 a.m. BST, 8 p.m. Eastern, and 5 p.m. Pacific. So join us tomorrow for our second to last session of lightning talks, and our last session will be on Saturday, and then we will have our keynote and unconferencing. So we're hoping that we can keep the excitement going, especially until Saturday morning, and then we'll all have a party and just relax after all the excitement and interest.
We would also like to again thank our speakers today. What amazing talks. Thank you all so much for putting those together. And also, we'd love to put up the sponsors slide and thank our sponsors one more time, Xander and Daily, especially for being excellent sponsors, and then Wherewithal, 2 Sigma, Phase Row, Discourse, Full Story, Accelerated Tech, and Mapbox for being our awesome sponsors. All of our sponsors have clickable links on our website, so you can go there, check it out. Check them out. Some of them have discount codes. I forget which ones. You'll have to click on all of them to find out. And And again, just thank you to all of our viewers as well. Those of you who bought tickets, those of you who are watching now or later on YouTube. Just thank you all for making Bang Bang Con so amazing. And we will catch you next time.